Hello everyone. So in the previous video we was discussing about the Rankine cycle which works on the regeneration. Is it? What is a regeneration? You are taking some amount of steam intermediate in the turbine and sending it back to the steam regenerator. So that was with one feed water heater. In this particular video we will try to analyze the regenerative Rankine cycle which has multiple feed water heaters. In the previous video it was only one, but in this case it has 1, 2, 3, 4 feed water heaters. Note, in the examination he may ask for 1 feed water heater or 2 feed water heaters or 3 feed water heaters. So carefully observe the question, what he is asking exactly, and then write accordingly. So for the maximum extent he might ask up to 4 feed water heaters. So I have just drawn the flow diagram for the 4 feed water heaters. Let us try to analyze this. So the heat steam generation process is very much same. That is the heat addition process, that is from sub n to 1. Takes place in 3 different processes. That is, one is in economizer, the second one is in boiler, and the third one is in superheater. After it converts completely into a superheated steam at state 1, it is allowed to expand in the turbine from state 1 to state 2. I note here I have to write state 2, which is missing. Just write it down. Write down state 2 here. Okay. So this particular expansion from state 1 to state 2 is being done in almost all 5 different stages. If you observe, it is done from 1 to 5, 5 to 8, 8 to 11, 11 to 14, and 14 to state 2. Why it is so? Because suppose if we observe, it is a unit quantity of steam which is flowing from the steam generator. So this is the unit quantity of steam. At state 5, it will be expanding from state 1 to state 5 with the unit quantity. So after state 5, that means at state 5, what I am doing is I am taking out M1 amount of steam flow rate. I am taking out M1's amount of steam flow rate, which I will do for the processing. We shall see. After that, first what are you doing? You are taking out M1 amount of steam flow rate. Initially it was 1, now you have taken out M1. So what is the remaining thing? That is 1 minus M1 will flow, that means it will expand further. Okay, it will expand further. Till where to where? It will expand from 5 to 8. How much? 1 minus M1. At 8, again what are you doing? You are taking out M2 amount of heat. At state 8, you are taking out M2 amount of heat. Initially it was 1 minus M1, you have taken out M2. So how much steam is being further processed? It is 1 minus M1 minus M2. Okay, 1 minus M1 minus M2 amount of heat is being expanded from state 8 to state 11. Okay, now after 11, that means at 11, what are you doing? You are again taking out M3 amount of flow. You are taking out M3 amount of steam flow rate. That means initially it was 1 minus M1 minus M2. You are taking out M3, so you have to subtract this M3 here. So it is 1 minus M1 minus M2 minus M3, which is getting expanded from state 11 to state 14. At state 14, again you are taking out M4 quantity of, that means steam flow, M4 quantity of steam flow. Initially it was this much, so this minus this will be processed further. So after state 14, so from state 14 to state 2, what happens? 1 minus M1 minus M2 minus M3 minus M4 quantity of heat is being expanded, and that same quantity of steam is being processed in the condenser also. What does a condenser do? Condenser is a heat rejection unit, correct? So it is a unit where the heat gets rejected. So that process is from state 2 to state 3. From state 2 to state 3, 1 minus M1 minus M2 minus M3 minus M4 quantity of heat is used to reject heat. Okay. From that same quantity, again it enters the WP1. So 1 minus M1 minus M2 minus M3 minus M4 quantity of steam enters WP1, which gets pumped from state 3 to state 4. Okay, this is the thing. Now, what happens to this M1? What happens to this M2, M3 and M4? We shall discuss now. M1 goes to the feed water heater 1. Okay, where it gets heated up from state 10 to state 6. Remember, state 10 to state 6 is your heat addition process. And where does this heat come from? Is it the new heat added? No, definitely not. This particular heat which is added here comes from the exhaust of the turbine. So it is considered as the heat quantity which is already present in the system. You are not giving a new heat to the system. That means you are not burning the fuel to feed water heater 1, to heat up the feed water heater 2 or any feed water heaters. You're just utilizing the heat which is available at the exhaust of the turbine to heat up this particular thing. So from where you are heating? From 10 to 6 you are heating up. So from 6 to 7 you are pumping the fluid. Okay, this is for the feed water heater 1. Similarly, it goes on for every flow which you are taking at intermediate stages. Okay, at intermediate stages, how much flow you are taking, you are heating it up and pumping it up. Okay, similarly it goes on like this. So this is how a regenerative Rankine cycle works with multiple feed water heaters. Now it will be very interesting to know how the TS diagram of this particular thing looks like, right? So we shall try to see what is a TS diagram. So here it is a TS diagram. See, the heat addition takes place from 7 to 1. Okay, you have to match the TS diagram with the flow diagram to understand the concepts very accurately. Always match the TS diagram with the flow diagram. So 7 to 1 is a heat addition process. So 7 to A occurs in the economizer, A to B occurs in the boiler, and B to 1 occurs in the superheater. So 1 to 2 is an expansion, complete expansion process. In that it has been split up into 1 to 5, 5 to 8, 8 to 11, 11 to 14 and 14 to 2. Correct? So 1 to 5 unit quantity of steam is being expanded. Okay, at state 5 M1 is drawn out. So remaining which is further processed is 1 minus M1, and I have explained you how it goes. At state 8 M2 is taken out, at state 11 M3 is taken out, and state 14 M4 is taken out, and this is the quantity of steam which is further processed. This I have explained you, right? Now all the blue color lines which are here, that means from state 3 to 4, state 15 to 16, 12 to 13, 9 to 10 and 6 to 7 all are pumping work, guys. So if I want to calculate the pumping work for this particular system, I need to calculate W3 to 4, W15 to 16 plus W12 to 13 plus W9 to 10 plus W6 to 7. And I need to add all those to get the total pumping work. Now, where does the feed water heater comes into picture? Feed water heater comes into picture for 4 to 15, 16 to 12, 13 to 9 and 8 to 6. The temperature is getting increased, right? Remember, even your 7 to A, which is an economizer, right? It is also a feed water heater. Economizer is also a type of a feed water heater where it uses the heat which is available at the exhaust to heat up the incoming fluid. So that is what the economizer means. Okay, so this is how it works, guys. So make the note of this TS diagram. Now analysis of this particular TS diagram. What are the different, how to calculate the different heat flows, how to calculate the workflows from this TS diagram. Now I'll try to explain this. This is very important. If you understand this, the problems would be very, very easy, and it is all based on a single formula. Yes, all the calculation what you make is just based on the single formula that you always have to multiply the mass flow rate with the enthalpy difference. You always have to multiply the mass flow rate with the enthalpy difference. We shall just take an example and then we shall try to analyze this. Now, he has derived the efficiency of a Rankine cycle with multiple feed water heaters with this particular example. So, I need to calculate if you go through this, so Rankine efficiency is given by net work output divided by heat supplied, where net work output is equals to net heat flow according to the first law. So net heat flow is QS plus QR, heat supplied plus heat rejected, and here QS is QS, so heat supplied. So you need to calculate what is QS and what is QR. QS is from 7 to 1, correct? So where does the heat gets added? 7 to 1. You might ask a doubt that, sir, heat is getting added from 4 to 15. Heat is getting added from 16 to 12, 13 to 9 and 10 to 6 also. No, all these heats which are added are from the feed water heaters. You should never take into account the feed water heaters heat added. Okay, only have to take from 7 to 1. Now, from 7 to 1, how will you calculate the heat flow? It is mass flow rate into enthalpy difference. What is the mass flow rate here? It is 1. What is the enthalpy difference for heats? It is always final minus initial. So final is H1, initial is H7. So 1 into H1 minus H7, it is H1 minus H7, which is here. Okay, similarly, for the heat rejected, where does the heat rejection takes place? It takes place from state 2 to state 3, correct? In the condenser. So how do you calculate the heat rejected, that is heat flow during this particular process? So it is mass flow rate into enthalpy difference again. So what is the mass flow rate? This much is the mass flow rate. 1 minus M1 minus M2 minus M3 minus M4 is the mass flow rate. And enthalpy difference, now you are calculating heat. Heat rate is final minus initial. So final is state 3, that is H3. Initial is H2. So 1 minus M1 minus M2 minus M3 minus M4 into H3 minus H2. So similarly here it is. Okay, then substitute the same things, simplify, you will get this particular thing. That is all about the thermal efficiency or the heat supplied and heat rejected. Now we will try to analyze what is the work done and the work done by the turbine, what is the work done by the pump. So now first we shall try to analyze what is the work done by the turbine. See, turbine work done will be from W1 to 2. This W1 to 2 is being split up into W1 to 5, 5 to 8, 8 to 11, 11 to 14 and 14 to 2, correct? So you need to calculate individually and add all the 5 values to get the total turbine work output. So how do you do that? First let us try to analyze what is W1 to 5. W1 to 5 you have to calculate. How do you calculate W1 to 5? So W1 to 5 is same formula again. It has mass flow rate into the enthalpy difference. What is the mass flow rate here? 1 into enthalpy difference. Now what are you calculating? You are calculating the work. For work it is initial minus final. So initial it's H1 minus Hy. So W1 to 5 is H1 minus Hy. Similarly, W5 to 8 you have to calculate now. W5 to 8, how will you calculate? Again, mass flow rate into enthalpy difference. What is mass flow rate? 1 minus M1. What is enthalpy difference? You are calculating work, so it is initial minus final. Initial is H5 minus H8. So it is 1 minus M1 into H5 minus H8, which gives you the value of W5 to 8. Similarly, for W8 to 11. Okay, W8 to 11. Mass flow rate into enthalpy difference. What is mass flow rate? 1 minus M1 minus M2 into enthalpy difference. You are calculating work, so it is initial minus final. So it is H8 minus H11. So totally it is 1 minus M1 minus M2 into H8 minus H11. So similarly you can calculate for H11 to 14 and 14 to 2. And that is what it is written here. Okay, the same thing is being written here, mass flow rate into enthalpy difference. Now let us try to analyze what are the pumping works here. So pumping works, how many pumps are there? 5 pumps. So 5 pumps, WP1, WP2, WP3, WP4 and WP5. So all these pumps can be analyzed in the same way again. So WP1. So what is mass flow rate into enthalpy difference? What is mass flow rate? The same mass flow rate will enter here. So it is 1 minus M1 minus M2 minus M3 minus M4 into work again, initial minus final. So it is H3 minus H4. Guys, the arrow marks are being missed here. So kindly draw the arrow marks. What I was discussing. Yes. So it is mass flow rate into enthalpy difference. Mass flow rate is 1 minus M1 minus M2 minus M4 into enthalpy difference. Here it is what? So initial minus final, H3 minus H4. Similarly for 15 to 16, pump number 2. Mass flow rate is how much? Mass flow rate is M4 is entering the state 15. So M4 into enthalpy difference, initial minus final for work. So it is H15 minus H16. So M4 into H15 minus H16 will give you the WP2. Similarly, M3 into H12 minus H13 will give you WP3 and so on. The same thing is being written here. Okay, kindly note it down. So this is how you will calculate the total pump work, the total turbine work, heat supplied and heat rejected. So if you master all this, the problems would be very easy. Okay, kindly note it down as stated in the video, man.